Hello friends, welcome you all to the next class of JCE Connect. We are into losses of prestress. So let's start with today's example. In this example we have a rectangular section 300 by 600 and it is prestressed by 5 number of wires of 8 mm diameter which are 50 mm from the top, 15 numbers of 8 mm diameter wires which are 83 mm from the soffit or the bottom. The initial stress in the wires is 1200 Newton per mm square. We got to estimate the loss of stress in wires due to elastic shortening of concrete. Modular ratio is given as 6. So now, why is this a different example? Because in this example we have two locations of prestress wires. One is 83 mm from the bottom and other location is 50 mm from the top. So this is an example where we have prestressing force applied in the top as well as the bottom section of the member. So now firstly we got to locate the CG of the steel, that is the CG of the reinforcement. As here we don't have reinforcement from a single point or in a single region, we need to first find a common distance with respect to the bottom at where we'll assume that all the pre-stressing forces are acting. That is what we say locating the centroid of the steel. So this can be done by your regular formula. Y bar is equal to A1 x1 plus A2 x2 upon A1 plus A2. So now here, as all the wires are of 8 mm diameter, that can be taken common from numerator and denominator and can be cancelled. So area term will not take in the calculation, which will make our calculation easy. Only what term will take is the number of wires and the distance with respect to the bottom. With respect to it we are locating our CG. So therefore y is equal to 5 into 550. So 5 is what? The total number of wires which are on the top. What is 550? Location of those wires with respect to bottom. Total depth is 600. Those wires are at a distance of 50 mm from the top. Therefore the distance with respect to the bottom of the beam is equal to 600 minus 50, which gives out to be 550. Therefore that term 5 into 550 plus 15, that is the number of wires, 83 is the distance with respect to the bottom, which is the given data, divided by 15 plus 5, that is 20 will be the total number of wires. Again I am reminding the term A, okay, which is pi by 4 into 8 square, because all wires are of 8 mm diameter. That term will come, pi by 4 8 square will come in the numerator as well as the denominator. Hence we are not taking it in the calculation. Only we are going with number of wires and the distance with respect to the bottom. Therefore we get y as 200. I value BD cube by 12, we get it as 54 into 10 raised to 8 mm raised to 4. Now eccentricity with respect to the concrete section is of 600 mm, therefore its CG lies at 300 mm, and the CG of the steel which we have found out with respect to bottom is at 200 mm. Therefore the eccentricity is the difference between both, which comes out to be 100 mm. Next, pre-stressing force is P, which is equal to number of wires, that is 15 plus 5 is 20 into 50, that is nothing but area of 8 mm diameter bar or 8 mm diameter wire, that is pi by 4 into 8 square, we get 49 point something, which is rounded off to 50. 20 into 50 into 1200, which is the initial stress induced in the wires. Therefore from the given initial stress, multiplying it by the total area of the steel, we are getting the pre-stressing force as 12 into 10 raised to 5 Newton. Cross section area is equal to 300 into 600, which is 18 into 10 raised to 4 mm square. Therefore stress in concrete at the level of top wires. Okay, so we are obtaining here stress in concrete at which level? Top level. Again in this example, again I am repeating, there are two levels in which pre-stressing reinforcement is provided. One is the top level, other is the bottom level. So firstly we are finding stresses in concrete at top or in the top wires. Formula remains the same. Fc is equals to P by A minus P into E into Y by I. So here P is 12 into 10 raised to 5, area is 18 into 10 raised to 4 minus P. Now here there are two terms. E is the main eccentricity which we have found out to be 100 mm. Next, what is 250? 250 is the distance of those wires with respect to CG of concrete. Again I am repeating here, as we are finding the stresses once at top and once at bottom. E is 100 in both the cases, okay, because it is with respect to the entire steel, whereas with respect to the location for the top, the wires are at 250 from the CG of the concrete or center of concrete. Okay, how we get that 250 is center of concrete or center of the section is at 300 mm. Top wires are at 50 mm from the top of the beam. So difference between 300 minus 50 gives us 250. So it is how we are getting that 250. So when you are making the notes, please take care of this point. So solving, we get the stress at top as 1.11 Newton per mm square. Similarly, stress in concrete at bottom level wires, same formula. Now what is the changes? E is the same, but the distance y, that is the distance between center of the beam, center of concrete, and the location of wires, we get it as 300 minus 83, which is equal to 217. Okay, 300 minus 83, which is 217. Hence substituting, we get the stresses as 11.48 Newton per mm square. So by solving, we have obtained the stresses at top as well as bottom level. Therefore, how we get the loss? We get the loss by multiplying these stresses with modular ratio, which is given as 6. Therefore, loss of stress at the top is equal to M into Fc, or the term sigma C is used instead of Fc, alpha C is used instead of M in some textbooks which you might refer. Therefore, the loss is equal to 6 into 1.11, which was the stress at top level. So we get the loss as 6.66 Newton per mm square, and at the bottom we get the loss as 6 into 11.48, which is 68.88 Newton per mm square. So from the total applied pre-stress force, these two are the losses. Let's move to the next example. I'll thank my friend Professor Naresh sir for sharing this example, which I did not have with me. Okay, so it is a question paper example and it is a big example, a tricky one. A post-tension pre-stress concrete beam of 50 meter span is subjected to a transfer pre-stress force of 9.38 meganewton at 28 days. It has a parabolic profile with 1100 mm deflection at the midspan. Determine the loss of pre-stress and find the jacking force required. The beam is subjected to a live load of 24 kN. Jacking is done at both the ends. Given data includes area of concrete is given, area of steel AS is given, I value is given. The data required to find the losses such as anchorage slip, loss due to relaxation are mentioned. The values of mu, K and other required values such as elasticity of steel and concrete are also given. See that the EC and ES values are given in GPa, that is gigapascal. So while taking, you need to convert them properly. Now when we look at this example, it becomes a half page example. reading itself gives us one complex. Okay, but if we start to solve, it is quite easy. So first we'll understand what is given. Initial pre-stressing force, okay, subjected to a transfer pre-stress force is given, that is initially pre-stressing force is given as 9.38 meganewton. Number of days is given as 28. Mid-span deflection is given. Now the extra thing which is given to us in this example is the live load, that is 24 kilonewton. So friends, you might have seen in the examples up to here, we have not taken live load in our analysis. That is, in your pre-stress equation, the term m by z was missing, okay, or m into I by y was not taken up to this step. But here in this example, for estimation of losses in practical conditions, the live load also is mentioned. Okay, so let's start with the example. So step 1, initial pre-stressing force given as 9.38 meganewton, converting to Newton, factor is into 10 raised to 6. Area of the cables is mentioned, therefore initial pre-stress is equal to force upon area, which gives out to be 1050.4 Newton per mm square. Now this is an important value in our analysis. This is the initial pre-stress applied, which is initial pre-stressing force upon area. Okay, so this is the initial pre-stress. Please mark it. It will be further required during the example. This value will be required. Next, loss due to elastic deformation. Since only one cable is pulled, okay, they have not mentioned number of cables and all, loss will be 0. Next, loss due to shrinkage. So strain caused by shrinkage is given by the relation which we have already noted down in the summary which we have made. 0.0002 log to the base 10 t plus 2. T is number of days, which is given as 28. So substituting the values, we get the shrinkage strain as 1.35 into 10 raised to minus 4. Therefore the loss is shrinkage strain multiplied by elasticity of steel. Okay, this you have solved, so let us not discuss in deep these things which you have already solved in the previous examples. So we get a shrinkage loss as 28.36 Newton per mm square. Only be careful while converting the E values which are given in gigapascal, and at this level you should be able to do it easily. So modular ratio will get as 5.5, which will be used further. Now let us calculate FC. What is FC? The stress in concrete at the level of steel. So equation is P by A plus PE into I into Y, or Y is equal to E itself, minus MI by Y, where M is the bending moment caused due to the loading. Okay, so here the loading will consist of dead load of the beam as well as the live load which is given. Both have to be considered and bending moment has to be found out. So this steps also in the previous examples we have done. So dead load of the beam, area multiplied by 24, which we assume as density, we get as 22.73 kilonewton per meter. Live load is given as 24 kilonewton per meter. So that you have to convert that area from mm square to meter properly. Total loading we get it as 46.73 kilonewton per meter. Therefore bending moment will be WL square by 8, which comes out to be 14603.12 kilonewton meter. This part we have solved n number of times in the previous topic examples. Okay, only difference is now in this sum we are including the dead load and live load also while calculating the losses. Previous examples we have not done this, hence that term minus MIY by Y also comes into picture in this example. Therefore now FC at the midspan, where we have a parabolic bending, we get P by A plus P into E divided by I minus M by I into E. Okay, so here this is the equation which is accounted for losses, same as we have done in the previous thing. 1100 we are using it as E value, which is the given data. So by this we find the stress at the midspan at 2.33 Newton per mm square. Now stress at the support where bending moment is 0, there is no eccentricity, is directly P by A, which comes out to be 9.9 Newton per mm square. Therefore, the variation is parabolic as well as a rectangle. Average stress, we get it as 2.33 plus 2/3 of 9.9 minus 2.33, which is 7.37. Now as the bending moment variation is parabolic, okay, and at the supports it is the variation closes, so we get here two values. One is the stress at the midspan, which is 9.99, whereas stress at the support is 2.33. Hence we take average of that as shown in the calculation. Okay, 2.33, which is the bottom, remains the same, plus as the variation is parabolic, we are taking 2/3 of 9 point height, that is 9.99 minus 2.33. Therefore, the loss is estimated as 1.2, which is the factor which is given, into FC, which is 7.37, into modular ratio, which we have found it as 5.5. Therefore, the loss is equal to 48.64. So this part you need to understand it properly. If you get any doubts, please don't hesitate to call back or you can text. Now next, stress is due to relaxation. 2% is given, that is 2 by 100 into the initial pre-stress, it is 1050.4, which you have calculated. Loss comes out to be 21 Newton per mm square. Next is loss due to anchorage slip. Okay, so that is 2 into 2.5 into 210 into 10 raised to 3 divided by the length is 50 meters, so 50 into 1000. Here we are taking 2 into 2.5 because the anchorage or the jack arrangement is at both the ends, hence the slip occurs at both the ends. Value of slip is given as 2.5, which has to be multiplied by 2 because the jacking arrangement is on both the ends. Therefore, loss due to friction. Now cable is pulled from both the ends, therefore alpha is equal to slope and x value will be equal to L by 2. Therefore the loss is equal to P naught into mu alpha plus kx. Substituting all the values which are given, P naught, again I am repeating, it is the initial pre-stress, which is 1050.4. Substituting value of mu, alpha, k and x, we get loss due to friction as 62.5 Newton per mm square. Therefore the total loss will be 0 because there is no loss due to elastic deformation. Considering all the other losses, we get the total loss as 181.49 Newton per mm square. Therefore percentage of loss is equal to total loss divided by initial stress into 100. We get that as 17.3%. Now last part, which is again a new thing, jacking force, that is the total force which needs to be applied. So the total force which needs to be applied will be the initial pre-stressing force plus the losses, because if we need to have the initial stressing force, the losses have to be taken into consideration while applying the initial force itself. Okay, so 1050.4 plus 181.49 into area of steel, which is 8930, we get 11.11 into 10 raised to 6 Newton. That is, jacking force required will be 11 meganewton. So this can be considered as a practical example where we know the span and we know the loading which is probably coming on that beam. Say it's a big industrial warehouse or something of that sort, and we know the floor loading also. So in that case, to take care of the losses happening, how much jacking force we need to apply while the pre-stress force is transferred can be calculated in this way. So it is a practical example. So this was a big example in which we estimated the different losses, okay, as well as we found out the jacking force required. Please go through the example. Again, I am repeating, if there are some changes required in the methodology, if the explanation is not sufficient, okay, please give the feedback personally. There are no issues. I'll take your feedback into consideration. Secondly, for maximum of the steps, I am trying to give an YouTube link as per your feedback. Hope you are keeping the things up to date. Remember friends, you are in your last semester. Okay, don't be relaxed as your juniors. Please be up to date and please complete the portion as it is explained. If there are any doubts, you are free to revert back at any time. So let me conclude today's class. Thank you.